All right, so let's get started. So, what we're going to cover today is, of course, tech for product managers, as you would have seen. I am Malay. You may know me from LinkedIn. I work as the director of product at Vyapar, and I also am the founder of Ayuda, which is basically this company which has training programs to let folks like you work on and get used to all of the stuff that product managers need to know. So, yeah, what we're going to do today is we're going to discuss all about tech for product managers, which is basically all about understanding exactly how product managers or what tech do product managers need to know, and how do you understand tech stacks, how do you understand databases, how do you understand APIs, and we'll try to keep it as practical as possible. We'll use the example of Airbnb throughout the session today so that you have something to connect to, so that you understand how this works. And by the end of the session, you will be in a place to really understand how tech works, right? One of the things that even existing PMs or more people who are moving in, they always have this question of, okay, how much tech should I know, or what should I know? The attempt is to today answer that question. The attempt is to today answer a few things around that, and that's what we're going to do today. So let's dive right in and let's get started. The first thing, and the first and foremost question that I would want to answer, that a lot of you ask, is how much tech should PMs know, right? And the very simple answer to that is PMs should know how apps work, which means that they should know how front end and back end works. They should know what the decisions taken by engineers mean. What I mean by that is that if an engineer comes to tell you that we want to do this on the back end, we want to do this on the front end, we want to do this like this, we want to do this like that, and a PM should know what is the repercussions of it. What is the true meaning of doing something on the front end? What is the true meaning of doing something on the back end mean? You don't need to know how to write code. You don't need to take technical architectural decisions. So if you want to segment it into two, how functioning of your product, how the functioning of your app is the first thing that you should know. What are the meanings and ramifications and repercussions of decisions the tech team are taking on behalf? What do they mean? That is something that you should be well versed of, but you should not be required, or you will not be required to write code, or you will not be required to take any architectural decisions as a product manager for any tech product. Now, let's start and understand the first fundamental concept of things, which is how do apps and websites work? Right? There's a very basic concept, very basic understanding. And if you follow me by the end of this slide, you will be in a position where you'll try and understand, where you will be able to, kind of replicate it and understand it very simply. We'll use a real example and then we'll use Airbnb as well, right? Now, how any app or how any website works is the architecture that you see on the left of your screen, right? Now, there is a client. Now, think of the client as you. The client would be your phone. It could be your laptop. It could be your tablet. It could be, a touchscreen kiosk on Bangalore Metro's ticket vending machine. It could be anything. But basically, anything that you as a user or any end user is using or interacting with is the client. Now, what does the word client literally means? And I often explain this with a very simple restaurant analogy. In a restaurant, if you go in and you are supposedly the client, you are the customer. Very similarly, in apps and websites as well, clients are meant to be very simply customers. They are very simply meant to be the end person who is going to benefit from whatever is going on in front of you. So for example, if I'm using a product, if I'm, let's say, using Swiggy, or if I'm using Uber on my mobile phone, the client is the device that serves me. So this device I directly interact with is the client. And in this case, the client would be the phone that I'm using it on. Right now, what is the responsibility of the client? What is the responsibility of the front end here? The client is also called as front end. The responsibility of the front end is to create the right requests for X. We'll talk about what X is. It's basically to take your input, which is what do you want to do? The fact that you want to book a ride, the fact that you want to order food, the fact that you want to book a restaurant, you want to book a hotel. It's the client's job is to take your wish and desire, convey it to someone that can fulfill that wish and desire. We'll talk about who that someone is, and then present a fulfilled version of it to you, right? So in this case, in the restaurant analogy that you're using, the waiter that comes and takes your order is essentially the client, right? So you are the customer. You have walked into a restaurant, you have walked into a hotel, or wherever. Now the person who's taking your order is the client, right? In this case, the phone is the client when you're doing it on an app or a website, right? Now, like I mentioned, what happens next is this client now takes this request to someone, right? And who this person would be? This person would be, in this case, someone called as a server, right? The word server itself means someone who gives you or services you. And in this case, in our restaurant's case, it would go ahead and give this order to, let's say your, how do I say, the kitchen, right? Or whoever is servicing the order from there, right? So, and in the case of Uber, it would go on to the Uber's backend, right? Now, sometimes the client would require to authenticate, right? Which means that not everyone should be able to enter it. So for example, in some restaurants, what would happen is, you would have to pay a cover charge or things like that. So similarly in apps, not everyone should be able to make a request. Only authenticated people should be able to make a request, which is why sometimes clients go through something called as auth, which is just short form for authentication, where it should ensure that only the right people are making requests and I'm not taking each and everyone's requests, right? So that is why people who have come in and sat on a table are authenticated in a way. Sometimes people who have a booking are authenticated in a way. So that is the same analogy for apps as well. So you don't want to everyone to be able to place a request to your client. Now, the second part of it is the backend, which does not happen in front of you, which is the kitchen in a restaurant, and the same, which is the backend in Uber or Airbnb or wherever, which is the server. Now, what does server do? What does the server do? The server actually has the ability to receive your request, process it, and create an accurate response to be going back to the client. And now the server requires a lot of tools at its disposal to be able to do it, because to be able to fetch different kinds of requests from different users from different places, there would be a requirement. In a restaurant, the example that we are taking, the menu serves that, right? In an app, the interface of the app serves that, because I cannot order grocery on Uber because Uber's interface doesn't allow me to do it, right? And similarly, I cannot order Chinese at a Darshini because their menu doesn't allow me to do it. So the same way, the server is configured at the backend to be able to service all the requests that the client makes. So in this case, those requests, in Uber's case, for example, the request would be to get a driver for the person. In Amazon's case, the request would be to render a product or to render a video that the user can see of the product, multiple things like that. But essentially, at the end, in the client and web server relationship, the server essentially is the person who is getting your request, using all the tools at its disposal to be able to service that request, right? And then going ahead and giving it back to the client for rendering it, right? Now, this communication, of course, has to have some protocols, right? Because otherwise, the client will say something and the kitchen would say something. Think of it as the slip that gets passed on the restaurant, right? That slip has a certain format, right? And why does it have a format? It has a format because it makes it easier for the server to process it. And that is what every app is at the end. It's a client which is facing. Now, as a PM, you can make the client extremely beautiful. You can make the client extremely intuitive. You can make it extremely easy to use. And then there is a backend or the server, which is where all the requests come. And then the server uses multiple things. These could be databases, APIs, essentially called services that they would use to fulfill the client's request. Almost every product that you use is just based on this very simple architecture, right? There is something that takes a request from you, that is usually a mobile phone and a laptop or tablet, and then there is something that services that request, which is usually the backend, right? So very clearly, the client is going to more be about the interactions, the UI, the flow, the buttons, the color, how easy can you make it for someone to use it. Whereas the server would be more about, business logic, algorithms, how data gets fed into things, how, where to fetch data from, how to authenticate users, and so on and so forth. So client will be more about how it looks and feels. Backend would be more about how it works. And that is exactly how the entire thing is run, right? Now, there are two ways in which any app works. And now we are going to just see a quick demo of Airbnb. So I'm just going to open that. I hope you're able to see it. So on your screen right now is Airbnb, which is, a service to allow you to book guests and so on and so forth. So now what is happening here? All that you see in your screen in the browser is from the client, right? Now the client, what the client is doing is that it is rendering this. When I type airbnb.com, what happens is The client, which is my computer, will send this request to who? To the internet, right? Because the internet is the only way by which it can transfer this request online. So this request will get transferred via the internet. Now, based on that, it goes to, let's say, the next step of people, which is Airbnb servers, because that is what is going to process my request. So how it works is, when I type Airbnb, the internet service provider, which in my case is Airtel, would have this information. It would then relay its information via the internet to the right domain, which is in this case Airbnb. And now it will give me all of this information, and it will give me all the information that is there from this URL and send back my request. Right. So what I've done when I've typed airbnb.co.in, I have just requested Airbnb to load its homepage because I want to see all the things that are available. So what is happening is, now Airbnb's homepage is in front of me. So what has happened is, the backend has given me a lot of information on this page. Now, there are two ways in which you could do this, right? The first way in which you could do this is when you are rendering this on the client itself, right? What I mean by that is, let's say this logo, right? Or let's say this bar, right? Or let's say the icons here, right? Now, these icons are not realistically going to change very often for Airbnb. So what a product like Airbnb can do is that they can go ahead and ensure that a lot of these repeated non-logic things, which don't require any logic to do, can be rendered directly without any thought process, right? So every time a request comes to load the home page, you can very safely say that the first 3-4 things are going to come here, right? Now, instead of sending it repeatedly, what Airbnb's front end, which is the client that you see on your screen, can do is, it can store it in a temporary memory, and that temporary memory is called cache. You might have heard that name different ways, CACHE, where basically what you're saying is that, okay, these are things that are not really used all the time. So why to load it every time from the backend? I'll just store it somewhere temporarily and note it. After maybe 3 or 4 days, I'll just clear it off and get the fresh ones, so that any changes that are made are now reflecting. But what about the things below it, right? The things below it are actually showing me options in Goa, North Goa, Mysore, and so on and so forth. Now, these are things that the client cannot decide on their own, right? How do you decide what to show? Now, in this case, what has happened is, I'm not logged in, right? Which means that they don't really know much about me, right? Which is why, there is no way for Airbnb's server to have a logic based on which they can show me. If they knew me that I was in a certain location or so on and so forth, they might do it. So what it is doing is that the backend is deciding that, okay, most popular locations where usually people book Airbnbs is Goa. So let's go ahead and show South Goa and North Goa apartments. And then all of this, right? The image, the name, the price, the rating, and all of this are things that the server is sending to fulfill this request, right? So in our kitchen analogy, what has happened is, you've come into the homepage, or you've walked into the restaurant. You have now not done anything, which is just you are sitting, which means that the server or the client has automatically understood, the waiter has automatically understood, sorry, that you require options to choose food from. So here, the client airbnb.co.in has understood that you require options to choose from. So let me give the menu to you, or let me give the whole catalog to you, right? Similarly, if I go on to a profile page here, now in this case, what is happening is, I'm still at a guest profile, which means that I have not completed my profile and there is no, this thing that is there, which means that they don't know much about me. So that is why the backend is giving this information to the front end, where it's saying that, okay, I know the name of this person, but I don't know anything else. Why don't you prompt this person with a button where they can go and fulfill their profile, right? So essentially what is happening here is very, very simple. The request is being made by my browser. It is going to first Airtel. Airtel then is routing it to the right domain through something called as a domain name system, a DNS. Not very important for you to know at this point, but it's basically the way in which Airtel is able to reach airbnb.co.in. And it's saying that, hey, someone sitting in Bangalore or wherever is requiring your help, and why don't and they have just loaded the homepage, right? So in a restaurant's case, you would be presented the menu. In this case, this is the menu analogy of whatever or wherever you are. right? Now, when I go ahead and click on this, let's say I click on this first or this one, what happens is now I am selecting a dish, which means that now the client here is passing this information to the backend that the customer that I'm serving actually wants to check out this flat in Arpora and know more about it. So the server is then hitting it back and saying that, okay, then this is the URL that will have all the information. This URL is what you can load. And then, based on this, based on the ID here, based on everything, I will show the photo, I will show the name and all of those kind of things, right? So the layout, the structure of where the photo will go, where the heading will go, where the hosted by will go, where these numbers will go, where the booking buttons will go, all of that is decided by the front end, because those are things that are not changing, right? So for example, if I open it here, or if I just open another hotel here, you see the way the layout is the same, which means the front end is the same, right? But what is going inside the photos, what is going inside the fact that there is a label here, the price, the button, what happens after you click the button, what happens when you're written here, who is the host and everything. Those are things that are different, right? So what the front end would do is they would code the skeleton saying that here, whatever name I get from the backend, I'm going to show it here. So now in the backend, the name of this property is Mandaram Homes luxurious 3 BHK retreat. So I'm going to show it here. Whatever main photo I'm going to get, I'm going to show on the left. The second photo I will show here, the third photo I will show here, and so on and so forth. Right? This is how every single page is loaded. So every single page on your app or on your website gets loaded in the same way. Of course, in some cases, when you don't want internet to be present, you don't want, or you want users to get some information without having to connect to the internet, you may choose to do a lot of this locally. So for example, what I could do is instead of going to a server via the internet, I can store all this information on my computer, right? I can store all this information of this heading, this photo, this thing on a certain folder, and I can direct the front end to say that, okay, don't go to the back end to make this request, actually make this request on the computer itself. So things like Microsoft Excel, Microsoft Word, all of those, they essentially work on this logic, right? Because there you don't need internet for it to work, right? So what is happening essentially there is you are going ahead and instructing the client, which is Microsoft Excel there, to only use the files stored internally in the system. There is a path, you all would know that path that is there of that file, and that is why it does not require any server interaction, or the server or the client itself is self-sufficient to serve the entire user, right? So that is how any front end to back end product works. But we'll now deep dive into each of these one by one. And before that, we'll just summarize into this and understand that there are two parts of this thing. And you might, be daunted by engineers talking about the tech stack that we'll use and all of those things. It is very simple. It doesn't mean much. There are just two parts of any product. There is the front end and then there is a back end. The front end has things in, or has ways in which you have written the interaction that you have, right? So HTML will be the structure of the page, where an image will come, where a title will come, where the bullet points will come. All of that would be written via a language called HTML. CSS will be all about the styles. So the colors of the page, the font, the spacing, the layouts, all of that. JavaScript, which is basically a way of writing interaction. So clicks, forms, dynamic behavior, animations, all of those things would be there. And then, of course, for mobile, there would be slightly different languages and different ways to do it. But basically, the front end stack that you would have is all about how you will present the information to the user. Right? Now, there are certain frameworks, React, Angular, etc., which you may hear sometimes, where a lot of these behaviors are inbuilt, right? Which is why a lot of people built it on React, which is why, because what would happen is all this combination of HTML, CSS, buttons, interactions, etc., they're all built within it. So it gives you a framework to easily invoke all of this, right? So I don't have to create the button every time. I don't have to create the layout every time. I don't have to create the interactions every time. I can just go in and, build on top of the framework, right? So the front end stack is going to be all about how things will look. And that is why, all of these things would be part of the front end stack. The backend stack again would have the language. So which backend language would you write it? Java, Python, PHP, Ruby, etc. And there also, just like frontend has React, Angular, all these frameworks, you would have backend frameworks like Python, etc., where all these common patterns that are there, right? All the common patterns that, how backends are stored, how data is stored, how login works, and all that. The common things that you use every single time, all of those are very easily creatable. And that is why you use the backend or infra stack from there, right? To store data, there is SQL, NoSQL, and all of those things that we'll study. But essentially, when someone says stack or tech stack, you don't need to get bogged down by it. Essentially, all they mean is what they're using for front end and what they're using for back end. And both have similar have purposes. A front end stack's purpose is to create the best visual layout, right? So, and the backend's purpose is to create the most scalable, logical way of serving all the requests. Because at the end, the backend has to scale, right? The only thing that makes the backend good is the fact that if it's serving 1 million requests right now, can it serve 10 million? Can it serve 50 million? Can it serve? Because the requests are all defined. So take the restaurant example. You can change the menu. You can keep improving the menu again and again. You can make it more beautiful. You can make it more interactive. You can make it, maybe a tablet where people can, see images of it. You can, describe it, or you can, make chef special and all of that. So you can keep improving the way your menu looks. But the only improvement that the backend can make, the kitchen can make, given the dishes composition, let's assume, is the same, that they can improve their efficiency, right? Once they get a dish, how fast are they able to give it to you? How many people are they able to service at the same time? That's the only logic that they are serving on. For them, of course, once the process of making the food is fixed by the chef, for them it's more about that process being replicated, and then how much or how many of that can you serve at the same time. The same thing works here as well, where the front end can be iterated and made more beautiful. That's why your apps go through regular changes of improving the UI, UX of it, and so on and so forth. But the back end, the only thing that you can improve in the back end is the scalability of it, the speed of it, the performance of it overall. And that is why there are two core concepts that we will learn to understand what happens in the backend, which are databases and APIs. So let's dive right into databases. Now, what are databases? There are three kinds of databases that exist broadly: SQL database, NoSQL database, and vector database. Vector database is more AI related. We'll talk about that. But for typical products, SQL and NoSQL databases are the two ways in which you have to store memory. Right now, take back the example that you had, right, which is the Airbnb example that we just saw. Now, to fetch all the listings, all the hotels, there has to be some place where all this has to be stored, right? Otherwise, how will the backend know how to get it? I mean, it cannot, generate the list every single time. There has to be some computer, there has to be some, for example, when we were doing it locally for Excel, what was happening was everything was, coming in from the same place. Everything was coming in from the computer that you already had. Now, in this case, the server, it has to come from somewhere, right? Some place it has to store things. Now, that itself is called a database. Now, there are two ways in which you can store it traditionally. Now, there is vector database as well. What is that? The first is SQL, which is structured query language. Now, what does the name itself mean? SQL is used when your data is structured in a very straightforward pattern and you don't have enormous amount of data. So to give you some examples, orders, users, the number of listings, transactions. Now, these are all very structured, right? Why are they structured? Because you know that the listing at Airbnb will have a name. It will have a owner name or host name. It will have a rating. It will have a location. It will have like 5 or 10 photos or whatever. So the structure of the data is very, very clear, right? The moment you have that, SQL databases come in. What you require in an SQL database is basically something that we will call as vertical scaling. Right? What is vertical scaling? What it means essentially is that it's the same thing being done again and again and again. So like I said, the only checkpoint or the only performance metric in this case for a database in a SQL database is how powerful can it become? How many can it serve at the same time? Because the structure of the data is going to remain the same. So tables like users, listings, restaurants, transactions, inventory. All of these are very structured. You know that in a Swiggy transaction, you have who has made it, what was the payment method, what was the amount, and then, was it successful or not, right? That's probably the only two or three things that you have to store. Now the game is that if you get 1000 transactions in a second, can you store it? If you get 10,000 transactions in a second, can you store it, right? So it's vertically scaling, which means that the use case remains the same. You just keep on going deeper into it, right? The second is a NoSQL database, where what happens is the schema is not fixed. What is the schema? Schema is essentially the structure of your data is not fixed, right? So in this case, what happens is a lot of modern apps, right? For example, let's say Google Drive or Dropbox, right? Now here, you don't know the structure that the customer is going to follow when they're going to store data, right? So imagine NoSQL for your LinkedIn feed, right? Or for your Instagram feed, or for your Twitter feed, or for all the logs or all the analytics that users are doing. Now these are immense amount of data, and there is no structure to it, right? There is no structure to the feed that is getting loaded every time, because there can be multiple things that can happen on that feed, right? You can show likes, you can show comments, and every single second that feed is getting updated. There is no structure to how the things are going to change, and the schema that, or the structure of that, is very flexible, right? You see a post now suddenly you see a reel, right? On the reel, maybe you see after the reel you see a ad, or maybe after the ad you see a comment or things like that. So a feed is a great example of NoSQL, when you essentially require a large amount of data, but you don't have a fixed structure on how you're presenting that data. When your schema is exactly the same, you want to show the same card again and again and again and again and again, and the same structure, then SQL is something that is used. When you don't have a structure, right, that is when you use NoSQL, right? So again, examples, like I said, logs are a great example. So if you want to track every single action that your user is doing, now there is no structure to it. When they've placed an order, it might be a completely different structure. When they've actually just scrolled through the home screen, it might be a completely different structure. So there is no structure to the data that you want to store, which is when you would use NoSQL. Most apps and most information, if you're able to look at it, SQL is pretty much used. Another NoSQL good example for something that you use is your Netflix watch history. Now your watch history has to change every time. The moment you click on something, it has to go there, and then it has to come at the first, right? So all of this, and your watch history can become as long as possible. Another example is your location, right? When you're on Google Maps and when you are on Uber, now there is no data structure, right? You can be here, you can be in Whitefield right now, and then you can take some really obscure path and go ahead from every places, right? So whenever you have a structure where things require to be more flexible, right, where they don't have a very solid structure, right? You want to go from here, let's say, to HSR layout, and now you want a live location feed to show, right, on Google Maps. SQL will not be able to do that because you don't know what schema to follow, what direction to follow. So that's why you would use something like a NoSQL, right? The last is more AI related, right? Which is, vector DB, which is saying that, okay, now the third use case that came in apart from, SQL and NoSQL was when your backend only does not need to fetch data, it actually needs to understand it. So there is no matching required, but you actually need to understand it semantically, or you need to understand the, quote unquote, feelings behind what was being searched, right? That is where vector databases came in. Of course, in another webinar, we'll talk about vector databases and how AI agents and all of that work when we go deeper into it. But I just wanted you to know that SQL, NoSQL are, of course, two great ways. But vector database is something that is now used for all of the apps that are AI related in terms of that. I can see like a little bit of confusion on, SQL, NoSQL. So I'll just repeat it once again. So for example, someone said that even for GPS location, you have lat and long conduit. So I'll just explain it a little more again. So see, to fetch someone's latitude and longitude coordinates is fine, but look at it from the frequency of change, right? When I am going through a path, when I'm going through and something is tracking my live location, the data is going to change every microsecond, right? Even if I'm sitting on this chair, I actually move from here to, just downstairs, my latitude and longitude will change. And then if I move one step again, technically it will change again. And one step again, technically it will change again. Right? Essentially, what will happen is because of this, there is a series of data, right? Like when I saying there is a time series of data that gets created, right? So horizontally, you would need to scale because of this, because essentially the same user basically require frequent changes or frequent magnitude of data, immense magnitude of data that an SQL database will not be able to provide, right? And of course, actual systems are going to use both kind of things. So your SQL will be used when things like I mentioned, your orders or your restaurants, basically fixed things where the structure is already there, they would use that. But NoSQL would be used, for things that changed every single time, right? So another example, like I gave for the Netflix thing, was your continue watching or your recommendations, let's say, right? Now your recommendations change every time you take an action, right? So there is no way by which you could structure and do a query and fetch your recommendations, right? It is again a time based thing where you do one action, because of that your recommendation changes, then you do another action, because of that your recommendation changes, and so on and so forth, right? So that is how you look at it, and use SQL or NoSQL, or use actually a combination of both. Most top products actually have a combination of both. They would have SQL and NoSQL both. SQL will be used for the standard tables that would be there wherever things are, this thing. For NoSQL, of course, whenever you require a large horizontal scalability for the same user, you would require recommendations, which will require a lot of things. Live locations will require a lot of things. So you would use NoSQL in that case. Right. Now let's look at a sample database as well, just to, solidify this and make it more hands-on and make it more real for you. So what I'm done here is there is a database schema, which is for Airbnb, and we are going to dive deep into it and understand what's going on here, right? So there are multiple tables that are here. I hope you're able to see this. And they are linked to each other in a different way. Now, each table has got this first thing here that you see with a key icon next to this. This is the primary key of any table, right? So this is the primary key of any table, which is the identifier of that table, right? So this is unique. This will not change. No two users will have the same ID. They can have the same name, they can have the same password. I mean, technically, yeah, they can have the same password, created at, updated at, phone number, description, image, everything else can be the same. But the ID in the users table is the primary definition of this, right? And that is why it's called the primary key. Now, there are certain other, let's take another example, and let's take reservations table an example. Now, there are certain other fields that may be primary keys or keys in another table and can be used to identify in another table. So in this case, for example, reservations has something called as user ID. And this user ID is the ID that is user's ka primary key. This is something that is called as a foreign key. So think of it as a large Excel file with all the things broken down into separate tabs. Now, all of these, let's say your users, your reservations, your rooms, reviews, medias are called tables, and all of them have data inside it, right? So when you're defining a user, so this means that whenever a user gets created on Airbnb, all of these things get created along with that user. So an ID gets created, the name is what the user has entered, the email verified time, password, if there is a remember me token, if there is a created at, updated at, phone number, everything. Whenever a room gets created on Airbnb, it's basically, it has home type, room type, total occupancy, total bedroom, total bathrooms, summary, address, has TV, has this thing. So all of those things are there, right? So essentially what happens is you go ahead and create all of these tables, and these tables then talk to each other, right? They talk to each other and talk about what is going on, or they basically, when I have to, for example, as a reservation, I have to find which room this reservation was in. Now, if I did not have this rooms table, I would have to store all this information that you see here on the room within the reservations table also. But now what I can do is I can only search for room ID, and I can find the room ID, and then that room ID has all the information. Right? So databases are a very simple way of structuring it, where you start with creating something called as table. Each table has got a primary key. Primary key's main use is to identify that particular table, and it's unique, which means that the same table cannot have two same primary keys. So every reservation is going to have an ID, every this thing is going to have an ID. In fact, if you go ahead and open the Airbnb thing that you are using, just look at this URL right here, right? Do you see airbnb.co.in/rooms? Now, rooms is the table that which is fetching from. Okay, let me open that again. Slash, you see this number here, right? This number is in fact the ID of this. So let me just remove all of this and just open this number. It will open it again. But now, did you notice what happened? I'll just go back. And do you see there is more information here? Check-in equals. Oh, okay. I'm sorry. I think I'm not showing the whole toolbar. 1 minute. I think you should be able to see it. Yes. Yeah. So what I was saying was, let's look at this right at the top here. Right. You've got airbnb.co.in/rooms/ there is a number here. So now this rooms is what the rooms table is. Right. And then there is a number next to it. This number. This number is the ID of that room. Now, look at what is written after that, right? The question mark, after the question mark, it's more information for the client to consume. So here the question mark has check-in equals this, checkout equals this, photo underscore ID equals this, and all of those kind of things. So there's so many things that are here that are available for it. Now let me just remove all of this and you will see the check-in and everything information will go in. So check-in at the bottom, you can see the check-in and checkout date is already there. I'll just remove it and enter it. So now you see the check-in and checkout date is gone. Why? Because now I have forced the backend to not give in this information to the front end. And whenever that happens, this would not happen. Whereas if I'm coming from this page, right? If I'm coming from this page, what is happening is the front end is getting this information based on a normal logic that the backend has set that, okay, if someone is searching, today is 29 November, someone is searching, then maybe show dates a week in advance, right? Because people would be searching for homes a week in advance. So that's why it's looked at it and given me a week in advance on 5th December. And then it's given me 2 nights, maybe as a standard for this, right? So that is how, databases are queried and databases are pulled. And of course, each of these have different, data types. So for example, your ID can be an integer, your home type can be a variable character, your room type can be a variable character. How many people are there has to be an integer. How many bedrooms are there? How many? Now, sometimes you may want, in bedrooms may have 2.5, 3.5, whatever. Summary has to be a text or variable characters. Sometimes you will have a yes or no situation as well, right? Where there it will be a Boolean in this case. So does it have a TV? Does it have a kitchen? Does it have an air conditioning? So all of those will be Booleans that would be there. So for each of these data types, you're going to have this, right? Now you can look at multiple templates. So drawsql.app actually has a lot of these templates that you can use to practice databases in general. It's basically linked towards, it creates a lot of these templates. So if I just scroll down here, you can see they would have a Twitter's databases template. They would have, they actually have a lot of this, and finding these are not that difficult. So yeah, essentially this is how this gets pulled in, right? Now, there are two parts to what we were discussing from the backend perspective that we thought about that we would have. We'll just load in the next one as well. 1 minute. The next part of what a backend does or what databases or what a backend is required to do is services, right? So one part of it is databases. The second part of it is something called as APIs. Right? Now, what are APIs? APIs are basically your windows or your backend's window to do more and more things, right? What I mean by that is, let's take a very simple example. Let's take an example of Uber. Now, Uber has to showcase rides that are available and it has to showcase the ETA as well, right? Now, I am, let's say, booking a ride here in Bangalore and the cab driver, let's say, is 15 minutes away, 20 minutes away, or 5 kilometers away, and all of that, right? Now, there is an algorithm to calculate ETA because of the traffic here. Of course, it would take variable time, sometimes more, sometimes less. We'll have to figure that out, right? So there is a long structure or thought that needs to be done. Now, if APIs weren't there, what would happen is Uber will have to implement this algorithm to calculate ETA all over again. right? Even though Google has already done a great job at it, Apple has done a great job at it, there is Waze and all of those apps have done a great job at it already. Still, someone who is requiring that ETA will actually have to do a completely full blown job of finding that ETA again. Similarly, let's assume that I want to authenticate if the user actually exists or not. Now, let's assume Google login is in there. Let's assume Facebook login is in there. What will I do? I will have to implement password and username. Now that is not secured because a lot of people keep the same password. A lot of people, they write it down somewhere and someone can see it and all of that, right? But that is what it was used to do, right? Everyone has to use that only. Why? Because there is no way by which I can borrow Google's authentication functionality and use it for my software. That is what APIs enable for the backend. So whenever a client is making a request, right, now you don't need, to go ahead and, take this example of saying that I have to build this entire structure fully again. And that is when I'm going to be able to implement it there, right? So Uber does not require to actually implement the ETA system on their own. They can just borrow it from Google and Google Maps rather, and they can say that, okay, this is the latitude and longitude of the car. This is the latitude and longitude of the person who has booked. Can you give me an estimated time and the route that the person is going to follow? And then just based on that, the APIs is going to return you an ETA, and that is what you can display to your end user, right? There are a lot of other API use cases. There are a lot of public APIs as well. Another example that is there, which is on Swiggy, right? Now let's assume that it's raining outside, right? Now, to know whether it's raining outside or not, I will have to build that whole engine, build that whole system, which tells me when it is raining at a particular location. And now Swiggy solves thousands and thousands of locations. They will have to figure out a way to get this. Whereas what they could use is they could just go in and use a public API, a weather API, which tells them what is the weather condition at a particular latitude and longitude right now. And the moment that happens, they can say that this is raining, I'm going to charge you a surge fee. Or this is raining, my delivery rider is going to be late. So essentially, APIs are a way by which you can borrow other software's functionalities and then serve the client better without having to build that on your own. So an example for this is when you have combined kitchens, right? Let's assume in the restaurant example that we were taking, there is something on the menu that you don't have, or something on the menu that you will have to build expertise in into knowing how to cook. Let's say you're going to a Darshini and you want noodles. Now they don't have the expertise to build it. So there are two ways in which they could do it. One, they could hire people who know how to cook noodles and then make them in-house. Or what they could do is they could externally integrate with a noodle store next door. Of course, physically it would have to be next door. Virtually it can be anywhere. Who can supply noodles as required? Right? And a lot of different restaurants actually do it where, sometimes on a grocery store, you wouldn't have something. You would just go and that person would go to another shop and get it for you. That's essentially what APIs are. It basically helps the PM reduce the effort. You can actually use a lot of the publicly available, or even a lot of these APIs are paid as well, where you can look at it. Now, of course, there is an API, which means that there will have to be some way of accessing it, right? It's very simple in terms of how you access it. You basically hit something that is very simple, which is something called as an API endpoint. Right? API stands for Application Programming Interface. API endpoint is just nothing but a URL that you hit. And when you hit that URL, you hit it with certain parameters. Right? Like in the Uber example, Google Maps will say that, hey, api.googlemaps.com is the URL that you hit. And then / you give me latitude equals this, longitude equals this, whatever equals this. You basically give me all the information in the endpoint. And then based on that, I'm going to give you a response. Now, of course, there are multiple things for giving the response. Not everyone should be able to get that response. You should be authenticated and all of that. But those are more, tidying up things. But essentially what and how an API works is that your apps or your server or whoever it is via the internet will reach this API endpoint. The client can directly call the API endpoint, or your server can call the API endpoint as well. And then they can call it with an exact format. So you would be required, the API when it's defined, we'll actually see a documentation as well. So when an API is defined, you would actually see exactly how you can get a response on that API. So this is rapidapi.com. You can use this as well to get it. Now this is again Airbnb's API. So you see there are 4 or 5 APIs here. The first is what I'm going to show is a search API, right? Now what will happen is these are the params that are defined, right? So when you hit this API, you are going to give these params to people, right? So see, this was the form that I was filling in the flow on the Airbnb as well. You have to send the location, you have to send check-in date, check-out date, how many adults, children or not, infants, pets, etc. You have to currency and all of that. And based on this, you would get this kind of a response. Right now, what is this response? This response is nothing but a JSON response where you would go ahead and see what are the things that are going to give. So here, when based on whatever you've put in, you will say that okay, there are so many items that have come in. What are these items? The first is a URL that has come in, which is airbnb.com/rooms/this. So this is the first search based on your location that has come in. What is the name, what is the position, how many bathrooms, how many bedrooms, how many beds, and all of that. Now this is linked very similarly to the database that you had as well, because this is an internal API. So Airbnb has written their own APIs here. So based on this, you would go in, right? Then it would also talk about the neighborhood, saying that okay, what neighborhood it is in, and it would give you 6 or 7 links of images as well, right? Secondly, it would give whether the superhost is there, whether it is a rare find, whether it's latitude and longitude. Now if you go back to this screen and if you compare this, look at what is happening, right? The first thing is you're getting a room, which means you're getting this, the title. Then you're getting 6 photos here, right? You're getting like 5 here, maybe the 5, and then there is show all photos. Then you're getting the thumbnail for the host, the image for that. You're getting the thumbnail of the host and image for that. So everything in this API response is coming. So you could directly just go into the database and query this, but that's not usually considered safe, because exposing your database directly between when you're querying is not considered to be the right way to do it. So you do it via APIs. So this entire response actually has the power to create and render this entire page, right? Everything, what this offers, all of those things. So see, amenity IDs, 35, 611, 4, 103. So these are all IDs. And what are the previews? Wi-Fi, heating, whether it's cancelable, what. So everything that you see on the page is actually coming from this API response, right? Similarly, if you want to go to listing details, which is another API, now this will have different parameters. So this means that when you are looking at a listing, you would have to have their ID, you would have to have check-in date, check-out date, and all of those things that are required. And then the response will be like this, right? The name, what are the images. So now when you're looking at the listing detail, there are more images because this person has added more images, and so on and so forth, right? There are a lot of public APIs that are available as well. So if you just go to Rapid API and go to collections, you will see a lot of APIs. So maybe I'll just search weather API that we were talking about. So there is something that this person has created now. So hourly data, monthly data. So maybe hourly data, if you see, you will see the params. So you will see which station to look at. Now there is a doc. That doc will tell you which station is where and so on. What is the date you want to look at? What is the time zone and so on and so forth. And then the response of this. Okay, the response I think is not enabled in this, but the response of this is essentially going to give you the data of what is the hourly weather like, or what is the hourly weather in that weather station from there, right? Similarly, there are other responses that you can also look at and see from here, right? You can explore public APIs on your own. Rapid API is good, Postman is good as well, and this gives you a lot of understanding. There are like fun APIs as well. So people have created APIs on movies. So all the movies, where they are streaming, are they on Netflix, are they on Disney, what is there is an API by IMDb. So what is the API, I mean, what is the IMDb score, and so on and so forth. So there are fun APIs as well that you could use, but that's another great way of learning APIs and understanding from there. And that is how your entire system works, right? Your client passes through and reaches the services. Now the client might hit the service on their own, or they might hit your backend, and then the backend might hit the service. But in either of the two cases, what will happen is, the API will be used to give the client the information, and then they will render that information. Right. So any feature, like we said, the one where we searched, or the one where we explored a listing, both of these use the APIs just like I showed, where you enter the location. Based on that, the search API gets hit. Now, based on that search API, the search happens, and then based on that, the results get rendered and get shown eventually. Right. Similarly, when you're going deeper into a listing, the listing ID is there now, like I showed you. And then that listing service would read what all information is there. And then those photos, text, responses, etc., will be shown to you eventually. Right. So that is all what I wanted to cover for the tech for PMs bit. Before I pause for questions, just a little bit more on our flagship program. If you're preparing for PM roles, our flagship program is a great help. What it does is it breaks down your entire journey into three parts, which is the learning journey, which is the interviews journey, and the AI journey. The learning covers different modules. The entire curriculum is available on our website as well, but it's the most in-depth curriculum available right now, where it covers each and every module that you require to become a better PM through live sessions on weekends. Similarly, we cover interview modules as well, and we cover all the AI things that you need. Someone was mentioning LLMs, RAG, fine tuning, evals, everything that you need, to be a very strong AI professional and an AI PM is covered. And one of the USPs of the program is connecting one-on-one with me, which is something that you could also do as part of the program for help on your CV, portfolio, doing some mock interviews, or clarifying any doubts as well. If you're interested, I will just drop the link of the form for the program in the chat. And if you're interested, please fill it out, and I will reach out to you immediately. You got an understanding of how these things are made and how tech works and all of those kind of things. If there are any questions that Gordon missed, feel free to reach out on WhatsApp. It's absolutely fine if you can do that. Just go to either.co.in, the URL. I just dropped the URL again for everyone. And you would see a connect on WhatsApp button there. You can reach out to there. And of course, if you're interested in the program, just download the brochure or just connect with me and I'll send it to you on WhatsApp. And then you can check it out if this is something that will help you in your journey. Right. Thank you so much. Thank you so much, guys. Really, really nice to know that it was helpful, and hope to do more of them. So see you guys next time. And also, if the program is something that you're interested in, do drop in, and love to see you guys. Bye bye.